coming, everybody, and thanks, Joe, for the very nice introduction. We're very honored, and thanks for the opportunity to be able to speak here. So, welcome. You heard a lot already about on the left. We start on the left here. ai-write, the project. Very nice. And Joe is the mastermind behind that. Since the very first ideas, we could do this project and install somebody as the main coordinator, but that's not so important. But she's really the one who has been there from minute one, so thank you for that. Then we have this final conference of the project, so welcome to this conference, and thanks for the whole MDU team for organizing this so nicely and setting it all up. It was great to have opportunity to be and come to Sweden for this. And with that we start into the project, the conference. I'm expecting a lot, really nice quality. Modest start, but after the coffee break it will get really good, so don't worry. And maybe the last question want to be answered, where is Hildesheim? Found out it's in Germany, but this is usually the map we show, right in the middle of Europe, right in the middle of Germany. We find the beautiful city of Hildesheim, and for our Nordic friends, we have that perspective. Hildesheim is very far south, right on the south edge of the, from here. Okay, and also we have a very wonderful web presence and wonderful social media presence on LinkedIn, where all that we are to be created, will be presented and shown and are easily accessible. So follow us and get all the updates. With that we can start to the content slowly. Where did it all start? Where did this come from? Maybe one of the milestones was the first fully automatically generated book that Springer Press sold in 2019, quite a few years back. Research overview on batteries and fully automatically generated, synchronization technology, and you see still there was a not so cheap price for that book. They still charge some money for that, for the computer work. And another milestone maybe was in GPT-2, a system where you could start first generative chat would start text could be processed, you write a little bit, and then this highlighted portion was the one that was created and generated, so shorter windows that we are used to now, but was already accessible online, but not with that success. And now, soon after that, a few years after that, just one headline here, Chat AI stuns academics in 2022 with essay writing skills, and this is the world we live in, and we did this project now, and that we are facing. Well, there's also some high expectation on ChatGPT that might be a little bit exaggerated. You shouldn't expect too much from AI, but that's also typical for students and maybe also for some academics. And also other attitudes, negative attitudes also soon came up. Now this is actually from this year, from this year. I just want to go back to the world without ChatGPT as an academic. Let's get rid of that. Bans were discussed, also some approach we didn't take in our project, and probably that would not be an adequate preparation of students for the modern world, so probably that's not a good idea as well. And it also reshaped whole professional fields, like software engineering, and a huge impact on software engineering, not only on writing. And nowadays, these language models are even a symbol of power, or a huge power component. I remember this recent event when Entropy developed a system that would discover all software vulnerabilities, and some people will get access, some not. And that shows how important this technology has become. And also interesting, the negative aspects are coming up. Suicides, people talking, getting convinced to do negative things by interacting with Chat AI, and we see that even the state of Florida sued the CEO of the OpenAI, of the company. We know the problems, the violence, suicide, addiction, and also the quote included reduced critical thinking as one of the things that you get, maybe seems to be getting sued for. University teachers here. Make sure next time you travel to Florida, make sure that you don't decrease critical thinking capabilities of your students before you might get arrested. Or don't travel to Florida, whatever. So we see lots of impact of the technology on our life and on many things. Yeah. So the history of writing got a new chapter. We could say the history in a visual nutshell. And with that, I'm coming to what will I talk about in this short presentation. First, I will look at effects of Gen AI on language and writing overall, some ethical issues and ethical uncertainties that we are confronted with, prompting, oops, I should have touched that. Helpless. There it comes back. Just you rise and everything under control here already since you came here. Unfortunately, you have left the University of Hildesheim and joined this university during our project, but one of the negative issues of this project. But anyway, maybe not for you. I'll talk about prompting, and at the very end, I will review some interesting literature on effective human AI collaboration. What could be models? Is the current paradigm the right one, or are there potential expansions, additions, and improvements? But I will also take time in the beginning, in 15 minutes, to fill these, as you said, the holes in the Swiss cheese. Maybe some of you are not fully familiar with the technological background of transformer technology, all of that behind. And I will take a few minutes to high level explain that a bit. And I will also introduce some of the project results. Joe did a good job already in that, but I will mention a few of our OERs as well. Okay, with that we dive into the technological background of ChatGPT. How does natural language processing work? How did it start? The main technology used to be information research or research. How do we find documents, search, for example, web search engine or before? And for that we also need to analyze content and match it to queries and so on. And this was mainly done just with lexical approaches and looking at words. I would say my class NLP or IR NLP, it was just about counting words. The words that are more often in the document, you will get a higher rank than other words in case you query for these words. So rather simple technology. We would count and then rank documents. Some a bit more knowledge, of course. You can fill a lecture with that. And then based on knowledge of Zipf, Zipf was a linguist in the 1920s. He was the first who approached linguistics as a quantitative field and said, let's just count words and see how often the words appear in a huge collection in the language. And he found this Zipf distribution law that you're probably familiar with. A few words, a few hundred words appear very often, and then many words are very rare. And this was then used as another important ranking factor since the 1970s, based on the work of Karen Spark-Jones. And he said, the words on the right that are rare, they are actually better for finding documents. They should get a higher rank, and these very frequent words, nobody cares about them, they will not give you good results anyway. They should be downranked, and then with that knowledge, TF-IDF and other ranking formulas, the search engine will develop, but still based on counting words. But even the Nobel Prize winner would say, be careful with words, you can trust words, they change their meaning, and they are really, how did Jose Saramago say, words are like shadows. So that is something something that the very recent development kind of took up and said, no, let's move beyond that word barrier. And this is, in a nutshell, the historic development from the 2010s. Search engine like Google worked with these lexical approaches. Then in 2013, word embeddings were invented for the first time. We had successful distributed representations. So I'll talk about that in a second. There were other technologies before, but they were not as good. And then based on these word embeddings in 2017, the so-called transformers were invented. GPT, now the T is a transformer. Also introduced that briefly, and then many models were developed, and this is until today. New models come up every week, but they're still based on this kind of technology. So from old computers with over GPUs, parallel processing, and now we have all of these new models. So in a nutshell, we go through and I'll briefly talk about static word embeddings and then a little bit about transformers. Now, so word embeddings are representations that go beyond this word level. One word is in the document or not, so 0 or 1, or maybe we count, but basically so-called one-hot encodings. And distributed semantics took that to a different level. Now we have short vector spaces, like 300 dimensions, for example, so each word is represented by 300 numbers. Which numbers? We'll see. We don't know why these numbers were selected. There is no way to explain that. They are simply learned by large corpora, and at the end, similar words will end up with similar numbers. That's basically the whole idea behind it. And the model learns, these words appear together in a similar place. Let's assign them similar numbers. They might have some difference in this dimension or in that dimension. What do these dimensions mean? We cannot explain that. That's the power of these systems. So, and since the 1990s actually, supervised machine learning is basically the most successful technology. If you have a few examples, or many examples, you can train a black box by just adjusting some weights, get numbers, get some input pattern, project into an output pattern by some simple calculation rules. Output is not as good, okay, tell the system and it can adapt. So it can map to learn from one numerical space into another numerical space. That works often very well. Some expert in machine learning told me, one doesn't even know why it works so well, but it simply works very often, as we see in our recommender systems, in whatever system that we do, AI system that we use. And what NLP had to do, or what linguistics had to do, natural language processing, was simply find a way to press word representation language into this black box problem, into the supervised machine learning model. Then, since then, it works wonderfully. But this was how do we map it? How do we find a representation? How do we frame our problem as a supervised machine learning problem? And the first steps were word embeddings, 2013. They simplified the problem into a prediction problem of one word. For example, there are other models, but basically we would go through text, huge corpora of text, and always take a window of 5 words. Each of these 5 words would become a training pattern. We have billions of training patterns, and then the system will slowly learn how this works. And what was the basic problem? Now we matched linguistics into a language into a supervised, or people matched that into a supervised learning problem. We want to always predict the middle word. We have 2 words, remember a window of 5 words, we want to predict the middle word. So we show the system the first 2 words and the last 2 words and tell it, what do you think is in the middle? And that turned out to be a solvable problem, works very well. And basically, that is transferred into, remember, each word is represented by 300 numbers. So it's transferred into a problem. We have one space of 300, 1200 numbers. These are mapped into 300 numbers. How is that done? box takes care of that. We update also, we predict a word. Of course, we never match exactly the 300 numbers of one word. So, okay, that's what you mean. This is the closest word. So let's also update the representation of the word. And that way, over many, many, many iterations, this turns out to work quite well. And you get good solutions for some problems. And this doesn't require a lot of hardware. This runs on a laptop in some time. Okay, now we have a space of 300 words. That similar words have similar representations. And what does similar mean? They appear in similar places. For example, something like black and white. Now we would say, oh, these are opposite. They must have completely different numbers. No, no, no. They often appear in similar spaces. And some things can be black as well as white. Can be black and white. So they have a lot of similarities actually because they appear in a similar space. However, the verb and a noun, they will have less in common because they will never appear, or very rarely appear in the same space in a 5-word pattern. Okay. So here we have again the update, and we learn that, and that works. And of course, as linguists, we know, yes, but words can mean very different things in sentences. That's not static word dependence can't do that. So we need another technology that was invented in 2017. And here the transformer starts with static word embeddings and then maps these over several black boxes or supervised learning into similar space, identical space. That says, well, at each position, I give them a sentence here, the input is on the lower side, we see again the word, each word is represented by 300 numbers, remember, goes into a transformer and is simply copied over several layers. However, each layer has a chance to check what's the rest of the sentence, what other words are there. Well, nowadays, we are way beyond the sentence, these always have longer attention spans, it's a bit shorter. What are the other words? What are the neighbor words? This word seems to be relevant for me. A pronoun would find, that's actually the noun that I have to attend to. And again, if this is trained with many, many, many examples, the systems obviously manage to solve that problem and find a way to adapt the semantics of the words. So again, this was trained in a supervised fashion with two ways. Some words were hidden in the beginning, and the system had to kind of reconstruct them and find, if I hear only 80% of a sentence, what's actually the rest of the words I have to guess. As we know, even in a conversation, if we don't hear a few words, we might understand the meaning completely. That can work. And another task was the next sentence prediction. So I have one sentence, and the second sentence next to it, and I have to predict 0 or 1. Is this the sentence that follows upon this sentence in a word or in a text, or is that second sentence from somewhere else randomly copied? So the system also learned that well, and at least it has some understanding of coherence, some possibility of text coherence. Surprisingly well. Yeah, here we see that, and we see again now, sorry, the input is on the top, the words are propagated through some layers, and the result will be booked. Okay, booked checks what other words are there, and how do we interact, how do these words interact with me. And then the result is, in the updated version, now the contextual word embedding is, my new representation for booked, it's like 55% of book, but we add 15% of room and 30% of hotel. Because we know, these are the words that in this case refer to booked, not something else, whatever. Can book a car or whatever. But this book in this sentence means this, so we include that. And that way all the words get changed all the time, some words more, a pronoun will get changed a lot, proper name maybe not so much, but at the end we get into some good representation. Now here is a nice YouTube video that shows how this is done. All the words are put into a matrix, how do they interact, what is the similarity, how much of which word should I add in the next level. And then this nice visual representation, we see a representation vector of creature. The sentence was something with a fluffy blue creature is slowly adapted and added. Words blue and fluffy are added to the vector of creature at some point, and we get a fluffy creature at the end. And that's kind of how it works, visualized here. Okay. And these vectors, you see that the black and white are kind of the words, the different weights of the words. There is these blue, red and green vectors. These are the learned parameters that the system changes over time, looking at many, many sentences. And then once the training is over, they seem to work pretty well. That's inside of ChatGPT and seems to produce good text. So we have this hierarchy, word embeddings, then we move to transformers, where transformers are the input, and the next level, of course, still a lot of engineering behind it. Now this has to go into a question-answering model. If somebody asks this question, what is a good answer, that has to be trained and learned again. You should be impolite and all of that. And we come to chat systems like ChatGPT. Okay. With that, also some misnomers that we can maybe correct here. Often we read this in newspapers, LLMs, they store probabilities. There is no storing space in the world to store the probabilities between all words for such long sequences. That's completely possible. They work with these distributed word representations internally, as I showed, and they output, or they produce probabilities for the next word, but they don't store this. And it's very complex math. Actually, all these calculations that I showed you could easily do on paper. You don't need math, you need calculus, you need fourth grade calculus, just additions and multiplication. Nothing else, that's all that happens. But you would need billions of sheets of paper. I'd get confused. The difficult thing is not to do these calculations, but to keep them organized. But basically, really simple things happen inside. LLMs have knowledge. No, blue, red, and green matrix, they don't have any knowledge. They just manage to produce great text, sequences of text, but no. They show involvement or intention or whatever, or might be nice. No. They just produce nice sequences of text that they can do very well, but that's it. So they're also not interested in you getting a good grade or you wanting to just brush up your text or completely change it. They don't know anything about that. So that's all up to the user. Okay, let's start with a few of these consequences before we move a bit to writing. LLMs already have changed in a few years the way we use language. People have looked into proper frequency distributions of words. You've heard some of this, and maybe you remember some words that often occur in LLM output. And here we see some words, well, Ebola, pandemic, we have a spike in the distribution. That's quite natural because these are things that happen, convolutional. Another technology for image processing became popular at one point in time. But the first 6 words are all spikes that come up in text when ChatGPT came out. So, are they produced by some external event or are they actually produced by ChatGPT? And this was done based on PubMed abstracts, right? So a big database for medical documents. Many, well, 1.5 million, so that's quite a lot. And we see these interesting spikes. Important, also some decreases. Important seems to be not so.
It's not important.
Well, see, I don't think it's important anymore, but it's significant and crucial potential. Delve, word that you probably all have seen, text created by LLMs. Another publication, that's another publication that looked at spoken language in YouTube channels. YouTube puts these subtitles, you can download these subtitles and analyze them. And you see some spikes for some words It just happened to come up when ChatGPT comes out. So even our spoken language is already affected by this technology. Here are a few of these words. Swift. Okay. This necessity, pinpoint. Anyway, you can have it. And this may what people, professors try to spot these words when they look at the assignments. Of course, not approved, but these systems has also all kind of a bias. A little bit older study, but it's interesting. Bias on the recognition, but then probably also on the production and what they put out. This is the error rate on word recognition for spoken language of some of these transformer-based models, and lower is better, no? And we see for different varieties of English and female male speakers, and we see, oh, Scottish speakers or New Zealand women have a higher error rate. They can expect systems to do worse for them than for Californian speakers. More training data seems to be probably that's the main reason. Yeah, okay. Irish English is not there for our friends. I thought I had such a great advance on my understanding of Irish English in this project until I noticed, oh, Lawrence is actually American. So my bias is still there. Yeah, do LLMs create the text we want or that we would write? That's an interesting study. I have a few slides on that. The experiment behind that is quite big, no? But simple. No? People asked 1,000 writers to produce text, write a short text on whatever. Then they created an AI version of that text, improved version, I think, or 2 versions, and gave that again to the writer. You can edit, you can improve it, and then at the end you select what is better, your first text or the final AI improved text. And then they also included 10K readers, different people, probably an online experiment, asked to judge these texts. Which of these? What do you think about the text? Is it good, opinionated? Who wrote it? What do you guess? What kind of person wrote this text? Then they will show AI and natural human-generated text. What were some of the results? Actually, the authors say, well, LLMs change these texts a lot, and AI writers are more extreme, more confident in their political opinions, more polarized. However, these were the observations of the readers. However, when you ask them, when they ask the writers, hey, wait a minute, actually, look at your 2 texts again, yours and isn't there a difference in the political stance? Isn't that political? They would strongly argue against that. They say, no, wait, that's the same. AI just polished up my writing. No, the perception is completely different. And also they asked about what do you guess who wrote this text, the readers. And typically the profile shifted to more privileged, more educated, more high income guesses. For example, see, AI is more opinionated, more extreme. On top we see the AI, and the lower the blue mark is for the human-generated text. So more knowledgeable on the issue. That's very interesting. So students are doing have a pretty good. It's a pretty good idea to write an AI text. Actually, if that is true, they seem to be more knowledgeable and more confident in your opinion, more extreme in stance, without us noticing, right? As writers, as we saw in this experiment. Higher quality, more formal, more informative, more original, and higher income. AI, probably somebody with a higher socioeconomic status wrote this. Think about when you use AI for writing an application. For higher income education, for professorship. Maybe write an application with AI. I highly recommend it. Yes, you say, yeah, but what about the human human stance, what about friendliness, what about human values, community values. AI again is much better than that. AI sounds more friendly, more optimistic, more community-oriented. So again, that gives us a lot to think. We think we just brush up our text, but a lot of things happen actually. And this is very very important finding. Not only students write, but 1/3 of our web texts are already being created with AI, according to this study. So that means AI is obviously changing the opinions, the stance, the political meaning, the tone. That has probably a huge impact already by now. Yeah, okay. This is interesting, a big study on what do people actually do. Question mark, is it really valuable as writing researchers to think about AI systems and chats? Do people really write, or do they just want to interact and ask for psychological problems or whatever? And two big, the publication by industry, two big services, Bing and Wildchat, they analyzed 20 million sessions, and they looked which sessions are only in English and have at least 2 interactions. And from this set, in the first case of 2.8 million sessions, they checked with some heuristics which ones have to do with writing, actually writing a text. And that's quite significant. Here we find the first one 9%, in the second study with Wildchat, I'm familiar with the system, 40% have to do with text creation, text checking, text writing. So yes, the work we do is actually very important. It's significant. The industry studies show that. And this study already also looked into what kind of interactions can we see there. Heuristically, not automatically done with 2.8 billion, that can be done manually. And typical things that we would consider as text-typical operations, I guess, rephrase, change the style, add some content, are very, very frequent. So yes, our work is important. People write text with this, we need to educate them. A lot of things happen without us knowing. We need to work on this. This is just what I said. Yeah, and we have all these threats, de-skilling, ethical issues on authorship. Now people get unsecure, unsure, is this still my text, kind of turn it in. We might have text of lower quality or even higher quality, changes. Do we have more or less efficient knowledge dissemination? Maybe it just looks more knowledgeable, but is it really, are we still interested, if we know about it, to read AI-generated text? As professors, we're not so much, but what about us? Does that change our perception of a text? And maybe knowledge dissemination becomes more effective. That's why we did our project. Remind you again of the project in the middle of the talk. And Joe has said a lot about it already. And we started also with a literature review. Some very interesting insights, but I'll quickly go skip them and refer you to other places. What was interesting is that at that time when we did this 2 years ago, already the outlets were very different outlets came, and we saw huge diversity of methods for such research. And remember that at the end. And of course, we also had found a lot of uncertainty and anxiety of students. Interesting, this publication shows that policy awareness doesn't have a huge effect. Students rely rather on what they think, what their ethical understanding. Don't do policies, they don't worry about that so much. And AI comes up as this distinct category. That's why we also in our ebook that is mentioned, there is a chapter on ethics and issues related to copyright. We have one OER that is discussing the copyright-related issues. UI is that can be used and reused in class classes. The main issues that we identified here, what should the student look for, maybe unintentional similarity. Sometimes LLMs just recreate what they have been trained on, they just recreate the text, and could be plagiarism. Be aware that somebody else might have copyright when you work for customers, and policies. Now, enterprises usually don't read policies. In terms of services, they often require you to transfer your copyright or whatever you input to them. That's, of course, also a big issue. Now that we are on ethical, on the ethical side is data protection, what you should be aware of, and that's, of course, general privacy rules. Be aware when you're posting there, this is all collected, used for training, at least as stated there, and kept forever, might come up someplace else. And don't ask about psychological problems. That's stored somewhere and probably sold to other people. Actually, they state that, they tell us. And that's good information for employers, for future potential employers. Whether you're constantly talking about psychological problems with the system. Okay, let's come to the human AI collaboration. What are good models? What are we looking at? History of writing teams, also the visual nutshell here. Nowadays we are moving from human teams with or without a hierarchical structure to the robot and the human. Literacy for prompting is definitely a huge topic that we see in the literature. I will not talk too much about it. There's also will be some talks in the conference. And there was this very highly cited paper by Johnny Can Prompt. Experts failed to use good prompts, and they found outside of writing for general tasks, prompting behavior unsystematic. People don't follow guidelines or rely on good knowledge. They opportunistic, overgeneralized expectations. For example, politeness will lead to better results in human-human interaction. Maybe for AI interaction doesn't matter. And even if people are shown effective strategies, they go back to their opportunistic designs. That's why we need education on prompting and training. One way to deal with that is train people, for example, about chaining. Don't do everything in one prompt. Go from one, go step by step. In this study, we have two systems, two ways of prompting, direct and chaining. And based on this study, chaining improves the quality of text, but also system transparency and a sense of I am in control. Now I can better interact. If I just write one long text, one prompt, I don't control anything. I just have to accept it. That often people even don't review their output. So their think through, transparent, controllable is perceived much better. And in ai-write, we also included prompting skills in our two OERs. How can we use prompts in a good way? Generally, microstructure, especially mentioned, emphasizing meta-linguistic strategies for prompting, use words like paragraph and all these things. There's insights, but again, we have DOI and you can directly use it. So, one way to look at that, and most of the rest will be taken from this paper from UKITA. They analyzed the literature on human-human collaboration regarding writing and asked what of this knowledge can be transferred to the human-AI collaboration on so writing with LLMs. And was they said, okay, there are these obvious things that AI is always on in human-human collaboration. We have, okay, when do I bug my partner again to write the next part? AI is always there, and there is no distrust. Maybe the person I'm writing with publishes by himself, or will he stop sometime? Also these issues are not relevant. But some others are. They say we have a discontinuous process, whereas before we went through the cycles of planning, reviewing, writing. We now pause during the writing phase and wait for output, and then we plan again, rewrite again, and so forth. They call this the discontinuous process. What I like very much about this paper is this overview, is that these are really important issues from human writing that we can transfer but adopt to the human AI writing. And I will go through 4 of them, sometimes do all of them, but I think this is really good point, a good position to move to next research. And first thing that they take now from the left, team from human collaborative processes. These are strategies are iterative, non-linear, interchangeable. Remember the graphic that Joe showed at the beginning is all these Mandl that was there. And we shift to a prototyping approach. What does prototyping mean? We create a prototype very quickly and continuously revise that. And for revision, works different than these other very non-iterative iterative ways, but in the prototyping process, we build something rough, test quickly, and go to the next cycle. So, and this is something that the tools should also support. And maybe they don't support it yet so well, especially they mention digestible chunks. So typically, right now, we don't even know how long is the output. Often it's too long for us to read. Is that helpful technology? No, actually not. Might be much better to create digestible, smaller output and give us a way to, like this is good, this is not good, and accept or revise certain parts. And they also created prototypes for these strategies and said this is how it could look like in the future. Maybe these are good strategies where we can do, in this case, a discharge letter for a medical personnel was the writing target, and you see, we have these elements that need to be there, digestible chunks. They are created individually, not as one big, huge text, and the user can accept them, digest them quickly, so yeah, this sounds good, but here I have to change something. No, then don't go into a new prompt, just change it right there, and the system can use this as input or as an improvement. So that gives you already much more control than huge output or document. There's no control there. And I think this sense of control is really something very, very important. If we don't have this control, writers in education, they will also feel lost and don't have a chance to create a good text. Another theme that they put out is supporting planning has been a good focus. Now many systems that we check in education, some outside OCR, they try to help the person organize a thesis, for example, from the very start. So it's necessary, maybe not so much. In the prototyping cycle, we might have to move more to more controls on the review and revision process. Writing process goes on, but review and revision is important in this prototyping cycle. And here they suggest less planning and more granularity of change needs to be available and accessible and controllable. For example, again, they suggest an interface where we have different types of modification that we want to do, and we can select them and see them and maybe accept some, not accept others, and these are at different levels. Actions, intent, we can debate whether that is the best distribution, but here we see we have different levels. We can just change grammar, we can change style, or we can change content, and currently, that's only one. If I ask the system just change the style, it might already also change content, I don't know. LLMs work unpredictably, and we need to give users more control. That would be one way. And this reminds me a lot of previous we had color coding on different types of changes that we could go through and accept or not accept. So some elements of that we already had. Huh? And the last topic I'll think is lack of clarity with authorship. We need more visual structures to check who did what, where are we in our text. And here they suggested this hierarchical structure of the text that maybe markers what was done already, what was revised, what is AI generated, what is human written. And that again will give me much more control than just ChatGPT, just create some text and take it or leave it. And very last thing is then writing as a social constructed by readers. Keep the reader in mind who is the audience. And LLM could also constantly check for certain reader profiles. Is this actually understandable for this group, that group? That I could select and iterate. And basically what a lot of these suggestions for the interface say, that's we need more elements, more interface options. That's actually not really very elaborate interface. If I look at ChatGPT, I can do one thing, click on yes, basically. And maybe we need much more graphic interaction again, and much more options and much more ways to work with the system. So concluding, AI chats were removed from graphical user interfaces, basically to only language-oriented user interfaces, type your text and that's it. And maybe we, for some, or actually for a lot of things, structuring, identifying certain parts with color coding and things, we have very good visual elements, so we had that for decades. Why do we give them up for things where they work well? We can even come to that conclusion without knowing anything about writing theory, but this paper puts this in more detailed. So, do we need more specific tools? Yeah, maybe that gives us more control, better support for specific things. Of course, we have to consider people are usually lazy and select the one tool instead of going to other tools. So that is a threat. Maybe that will not be accepted or be less accepted. And we saw that already in our first project, but people didn't like Coolbot so much because that's too much detail. But if we give them more control over the details, they might benefit that. So we have this multifaceted nature of AI writing. We need to give users a sense of control, otherwise all the pedagogical input is useless. If they can put that into the tools, into micro interactions, and knowledge about the writing process from you must go into the tools. Now, where can we really create better tools and support this process at the macro level, and without kind of teaching strategies around that. We're implementing this now in, for example, in prompting, but maybe there's also other ways to add to that control. And then, of course, we also need to disseminate the knowledge to users. Why is it useful to use the system, and which strategies can you implement when? So probably, as being expected, students have to know probably more about the writing process. But maybe reluctant to pick it up. So, a lot to do for us. And we need methods from various disciplines. Most of the work that I presented was published in venues in human-computer interaction, but includes knowledge from writing, and they have different methods, prototyping, and so on, or NLP. We actually do NLP studies, so there must be much more understanding, visual understanding of systems, models, theories, and methods. We need to go into accepting methods from other disciplines. Okay, almost at the end. So doesn't need the 1 minute thing. And so far, none of that was AI generated. All of my texts were humanly generated. But for the last slide, I decided what's actually a good slide to say thank you at the end of a talk. And I asked one of these models, what should I do at the last presentation slide of a keynote talk? How do I thank the audience? And when the instructor said, pause after your final slide. Let the message sink in. Hold silence for 2 seconds. Okay, and that creates impact. Yeah, great. Avoid, that's all folks. the ending of the talk. Or robotic, maybe good night, it's not night anyway. Okay. But the last thing I really liked, the final line. Let's go out there and write that future together. It's a powerful, action-oriented call to action. And that's the best thing. It leaves you energized for the coffee break.